Okay, is everybody seeing the screens properly there?
Good.
Looks good. Okay. So some of the dates you want to put in your calendar there. We have Hamfest coming up. It's at Rick Riel the 21st of February. We have CPAC coming up in June. Looks like June 5th and 7th. So we don't want to miss that one out there at the coast there in seaside there. So it's a really cool event. It's basically the Pacific Northwest ARL sanctioned get together. There's tons of good training that goes on there. There's also very good swap meet there. You get to touch and feel and talk to vendors. You have all the major vendors show up there, and you can touch and feel and play with the actual radios there and get some idea of how they end up working. So, great thing. This year, there's not going to be a DX convention down in Visalia. It looks like they're going to be doing it every other year. There's some other smaller conventions that they're planning on doing down in California, but not the big DX convention. The final one you want to make sure you put on your calendar is actually, let me hit not the final one. Oh, well, you got two final ones. 7QP, that's May 2nd. And so there we always do an outing there, and it's kind of getting all your camping equipment out and see if it still works after the long winter. So it's kind of the first spring outing. So that's May 2nd. You want to block off dates from April 28th through May 3rd for that event. That's a lot of fun. Very educational for any newbies that want to get into a little bit of contesting, and the food is fabulous, absolutely fabulous. We do a good job on the food. Okay, the final one is field day for this year, 2026. If you haven't figured out how to write the right date on your calendar, remember we are now in 2026. So that's June 27th and 28th. We usually set up the day before that. So we do the setup on the 26th, and that will be at the Willamette Park this year. So that's all the big dates that we want to talk about. So uh, just so I get a chance to talk about a little bit of DXing and stuff that's going on out there. This is the top, I don't know, 10 or 12 list of expeditions that are out there operating right now. And so you can look to see at the wonderful countries. I have to say, a lot of this I've backed into accidentally. Some of this is really pretty easy to get on HF, and it's a lot of fun. There's one there. Let's see if I can find the darn thing. Ah, there we go. Dushio or something like that. KP5. If you remember KP5. So that's the call sign for it. That's a little tiny dinky island, not too far in the not too far off of um, Jamaica. Yeah, I think it's off the east end of Jamaica. So there's a little dinky island there. It's actually semi-arid. It's not like a tropical island is. But they used to use it for a bombing range, and then now it's been turned into a bird sanctuary. And they've gone through there and eradicated all the weird animals that they had on there that was causing problems with uh, birds nesting on there. So that is, they're using a RIB. That's called a remote in a box. So that's a complete operating uh, system with all your transmitters, tuners, power supplies, networking, radio communication. They take and roll that on shore, set up antennas, set up a generator, plug it into this thing called a RIB, remote in a box, and that provides all the radio interfaces. And then there's a little antenna on that. And that antenna heads out or provides a network communication to a boat, and they set out in a boat in a nice air conditioned environment. Good food, nice place to sleep at night. Don't have to worry about insects and crawling critters getting into your tent, and a decent bathroom to end up using and taking a shower in every morning. So that they're not running any power. And I have to say, the guys here on the West Coast are really having a hard time getting this guy. The East Coast guys, no problem getting in there, but they're not running any power. It's only 100 watts. And so it makes it pretty hard for us here on the West Coast. But that's one that I have been chasing for the last 3 days, and I have not got them lassoed. So a lot of fun out there for DXing. Well, for DXing and yeah, well, this is all DXing stuff. So anyway, good, nice list here. So let's get on to the program. So this month, I'm going to talk about automation and things you can do to kind of the big picture stuff as far as automating things in your system to make life easier and different things that you can uh, bring into your ham shack to make life easier to take and run the thing. So this is going to be based on practical experience. So it's again, it's back on me. My practical experience is what I'm going to be showing you. Doesn't mean that it's going to fit everybody's need, but please think about this in an open mind and think about how some of the things you can do on your own ham station, on how you can automate things, certain things there. So it's also going to introduce a little bit of discussion about Linux, the other operating system. So every morning, I'm up by about 7 o'clock. And so I go downstairs and make my breakfast, get some coffee and cereal, and flip out my cell phone and end up turning on my ham shack. So I turn on my radios, my PCs, my amplifiers, and everything. All that gets done from my cell phone. So while I'm waiting for my coffee to finish doing its final perking, everything is warming up in my ham shack. So when I get up to my ham shack, all my equipment is up and running and ready for business. And I like getting on every morning. I'm always on the air by at least 8 o'clock. Sometimes I'm up there earlier chasing some DX on lower frequencies like 160 meters and 80 meters. So this here is my main screen. This is what it looks like. A little frightening, but that's what it looks like when pretty much when I get up to my ham shack. All of that stuff is up and running. So over here on my left side, actually, let me start over here on the right side. Everything starts over on the right side. So here are the lower right hand side. That screen there, I don't know if my cursor is showing up on that, but it's basically that I run a Flex radio. So the Flex radio has 4 receivers in it. So I always run with 3 receivers, one for single sideband, one for FT8, and the very bottom one, I do searching on other bands, like looking for openings on 6 meters or checking to see what propagation is like on 10 meters. But that's the guy I do all the hunting on, is that very, very bottom receiver there. So from that, if I move over to the left side of the screen, that's all FT8. So there's the old waterfall, the normal screen that shows what's going on. And then the bottom part is my headhunter out there for, excuse me. Bottom of the screen there is JT Alert. So that's going out there finding all the stuff that I can't see by my eyes, and it'll tell me if there's stuff that I haven't found. Right in the middle of the screen is a new entry into what I've been playing with, and that's called Ham Clock. So Ham Clock will get into a lot of other little things in there, but that tells you a lot about what's going on propagation-wise, where you should be going to, what your solar energy is, what the sun looks like sunspot numbers, solar flux, all that kind of stuff. It'll show you on some of the other panes there, but we'll get into that a little bit later there. And then up in the upper right-hand corner in the background, that's my logging program. I run Ham Radio Deluxe just because I like things overly complicated. It's a very good system to use if you like a little bit more feature rich. has a lot of stuff in that thing. So I really like Ham Radio Deluxe up there. So that's what my primary screen looks like. So this is what my secondary screen, the screen off to my right, and that has all my operational stuff. So in the upper left, that has my amplifier, it's an RF2K, it's a solid state amplifier that'll run 2 kilowatts. The next one below that is from let's see, come on, what is the name of the? Anyway, it's another solid state amplifier that is also capable of running 2K. So I really like solid state amplifiers. You don't have any warm up, and they just you can really run some hardcore power to those things. Lower right is my rotator controller that I can easily connect it up to um, my logging program. So if I spot something, I click on it, hit another control key, and that antenna will automatically rotate around to get the proper coordinates for the station that I'm going after. The next one up is a little module for um, uh, for dummy. Try this again. So this is another add-on for my radios that I have that I can use control it and also gives me some other indications and tells me what's going on with my radios, with my Flex radio. And then the guy up in the upper right hand corner is a little guy called Ham ID. This is a little program that really like because we're supposed to ID every 20 minutes or every 10 minutes. And so a lot of times when you're in a rag chew, you kind of lose track of time and you forget to ID. So this guy here will end up reminding me what the heck to do out there. So I like that. So that's my other display. Pretty a lot of stuff that's up there. Not much free room where I can stick things in. So how do I do this? How does all this work? How do I turn all this stuff on? So my particular like is called package called Home Assist, and it's always you usually see abbreviated HA out there. It's a free open source application. It's like if you ever done any home automation, it's like what you get with Alexa, like with Google Home or with Apple HomeKit. Very similar with capabilities, but a whole lot more. A whole lot more. There's other home automation systems out there. This is probably one of the richest ones that I have found, and it will basically integrate with almost anything that you can imagine. If it steps on Wi-Fi, you can probably find an integration with it. But just it's insane all the stuff that you can integrate with the Home Assistants. So Home Assistance is a Linux-based system. It can run on either a Raspberry Pi or it can also run on a VM, a virtual machine. And we'll talk more about that a little bit later. But it is just such a cool thing as far as things you can integrate with it. Um, my hot water heater is integrated with it. My weather station's integrated with it. My my HVAC system, it's also integrated with it. I run my sprinkler system on off of this thing. There's just if you can imagine it, you can probably find an integration. You can probably find a way of fitting something into Home Assistance. It's really cool. So here's I don't know how well this is coming across, but this is kind of the opening page of Home Assistance. You can see that they're up on the very top. There's some tabs there called Home Integration, Power Monitor, EcoWit, Water Heater, Thermostat. So these are all more pages I can bring up that has a whole lot more information on here. So this home page, I'm only showing about um, 1/3 of the length of the page. It goes on and on and on and on with all kinds of stuff in there. So this is kind of a collection of a whole lot of stuff that doesn't nicely fit in some of these other categories that I have out there. So on that, I've isolated the one little area on that big page there. So it's called Ham Power Control. So in that, I have the ability to turn on my Flex radio, my RF kit amps, and my Expert amp. So all of that is easily turned on from my cell phone. I also have another thing it's buried back in that same page there in another place, but I can also turn on my computer up here. So it all that stuff turns on. So when I get up here, everything's booted up. I have it set to automatically log in, and all of those apps are all set up in a nice little folder where the operating system goes through there and does a startup of each one of those applications and starts those things up automatically for me. Really cool. So let's talk about how some of this stuff works, the inner workings of it. So the first thing is that, and you may want to do this, you may not want to do this. A lot of people don't like your laptops or your workstations to automatically log in. But if you do press your Control Windows key, R, it'll pop up a little box. You type in the net PLWiz there and press enter, and then it'll pop up with your user account. And then there's a tick box in there that says user must enter username and password. Anyway, unclick that thing and then set apply, and you can back out of that. That means when that box starts up, it will not ask you for a user code password. So, but people may or may not like that. The next one is how do I get all these applications to start up? Again, on Windows, control or a Windows key plus the R key. That brings up the same dialog box. Type in shell :startup. That brings up, and you hit enter, that brings up a view of a folder that shows all the startup stuff. So in that folder, you can go through there and drag and drop. You can take your little icons that you have usually on your left or bottom of the screen or right of the screen for the application that you have, make a duplicate of it, or make a shortcut of it. I'm sure everybody has played with Windows enough to know how to make a shortcut. And you just take that shortcut and drop it into this folder. Now the key is you want to go through there and drop this in the order that you want things to start up. So it's important that all of this needs to start up in a certain sequence. And this guy, Windows, just barely does it correctly. But it'll all start up those applications in your on your PC. So it's really cool to see this all work. It just magically works when it logs. When you start things up, your computer comes up, automatically logs itself in, and after a little bit of a pause while it's busy loading drivers and stuff, then you see all these applications will end up popping up on your screen. And this list here is not the whole list there. It goes down a little further. I just cut it off, but there's another half of the list down below this guy here of the things that get started up. So that's talking about Windows, how you end up, a couple ways that you can do it. You can use any kind of automation tool out there that can control things, and you can then use your little laptop or use your cell phone to end up turning things on. So in the ham world, there are some really nice applications out there that only run on Linux. And so and people don't like Linux. It seems like too much command line stuff, blah blah stuff like this. Well, there's a lot of command line stuff, but these days Linux has come a long ways. So any of these applications that we get into, all of these are done, it's cookbook style. It basically tells you how to end up loading up Linux, whatever version you want to and why. And then it gives you the command lines where it's just nothing more than a cut and paste, cut and paste, cut and paste into a command line of exactly what those commands are. And next thing you knew, you have that application running on Linux. So Linux these days, there are a lot of cool GUI stuff like you get to on Ubuntu, the newer stuff. That's virtually all GUI type of interfaces that you use for turning things on and making things work. But some of the older versions of it don't have all that nicey stuff. So the guys I want to talk about here is Ham Clock, and we'll get into why I think that's a really cool thing. Pi-hole, it's not really a ham um, application, but it has some real advantage, and we'll talk about what those advantages are and how that plays into the strategy here. And then we'll also talk about Home Assistants. But all of those, all three of those things, they're all textbook, cookie cutter based, how you end up installing that and stuff and making it work. So there are many different ways to run Linux on Windows. Everybody thinks, oh man, I got to buy another PC. I got to put all this stuff on um, a separate PC. I got to learn how to install the kernel on it, blah, blah, stuff like that. Well, believe it or not, there's many different ways where you can take Linux. I have Ubuntu, you have, I don't remember, I got about three different variants of different kinds of Linux running on Windows right now. So one of the systems out there on Windows, and that's called Windows Subsystems for Linux, WSL. So whenever you see WSL, that means the Linux, or that means the Windows-based stuff. So they make a virtual machine. It has, all of the Windows type of flavor as far as the complications that it takes to make that work. It's pretty simple to get started. It's a little more complicated to figure out some of the stuff after you get it complicated and you need to do any tuning on it. But it does work, and I can say that if you want to, you can go ahead and use it. Lots of good online information on. The one that I kind of like is Oracle's VM called VirtualBox. VM, whenever you see it, that stands for virtual machine. So it says like there's another PC. Anytime you see a VM, the same way with WSL, it's like another PC running on another PC. Sounds a little confusing, but it all works out very, very nicely out there. So personally, I like VirtualBox. It's simple, basic, not overly complicated, and it works, and it's free. Mm. Sorry about the cough. I'm still kind of drying out from a cold that I caught from my grandkids during Christmas. Um, so, so anyway, those are, and also, I'm just saying VirtualBox because I'm acquainted to with it. There are many, many other variants of VMs out there. Most of the bigger, heavier duty ones are much, you have to pay for them. I like VirtualBox because it's free and it does everything you want. It's basic. It does exactly what I need without a bunch of complications, and it's insanely stable. It just works well. You don't have to worry about Windows coming along doing updates and breaking things. So here's another alternative that I really kind of like, and that there's a lot of stuff I like leaving running 24 by 7 and just like a server, like a little tiny mini server out there. And not like a PC. That my workstations I start up and shut down every day. So it's always on and off. But there's other things that I like to just be able to run continuously out there. So there's little mini PCs out there, and this is a picture of one version. There's lots of different versions out there. The neat thing is they're about the size of they're smaller than a cigar box, about two-thirds the size of a cigar box. They usually run an N95, N150 or something like that. So it's a small processor that usually ticks along at around 3.5 gigahertz. It's a four-core processor. I like buying ones that have 16 gig of RAM, 512 gig of a disk, not a whole lot, and it's all M2 disk, so it's solid state disk, really, really insanely fast. And I usually buy them with Windows 11 Pro. And the nice thing is, these are under $200. Really, really darn cheap. It's not like buying a whole big system. So I think the current price is maybe $189 right now, but it's under that. And if you want more processor power or think you need more processor power, that all scales up and proportional to the amount of money you want to throw at it. Another really good feature about but these little boxes, they only take 15 watts to run. 15 watts. So they just sip on power. They don't use much power at all. This guy here, I turn it on. It runs 24 by 7. I never turn it off. I being this Windows 11 monthly, you have to deal with doing the Windows updates. So that's the only time that it kind of restarts. I run the thing headless. So if you don't understand what that term means, headless, that means there's no keyboard connected to it. There's no display connected to it. It does not have any peripherals connected to it except for power and Ethernet. That's the only thing that's connected to it. And then from my workstation, I can use my remote desktop or VNC as another product to end up connecting to it. And it's just another Windows on my workstation that I'm connecting to it. My keyboard, mouse, everything works on that station. Really sorry about the cough. My apologies. So on that little tiny box, I have two different weather stations that run on it. I have two databases that run off of it. The weather stations use databases to shove stuff in and out of. I have a surveillance system out there. I have two medium resolution cameras and two 4K cameras. Those 4K cameras, that's a lot of data that's flowing through that thing. And that little box is not necessarily made to do that, but it does a very nice job of processing all the surveillance data. I have a telemetry system that collects data off of Coffin Butte, one of our repeaters that we have not far from me, and that also gets pushed into a database. I have three Linux virtual memories, VMs on there running off of that same virtual machine that I talked about. And I have Home Assistants running on it. I have Pi-hole running on it. And I have Ham Clock running on it. So of all of those entities out there, probably Ham Clock is the most aggressive as far as using up processor power. And this thing here, it mainly runs about 35, 38% processor utilization. If Ham Clock is doing some other stuff, collecting more new information, that may push up to about 40, 45% of processor utilization. So not too overly aggressive on the processor, but I don't know that I'd want to push it any more than that. So I'd mentioned a Raspberry Pi. So Linux and Raspberry Pi and those applications that I previously talked about, those will also run natively on Raspberry Pi. So if you like a little cheap little processor that's about the size of your hand, you can put that on a Raspberry Pi, and they're really small, really neat. And the economy of those things have kind of gone by the wayside, but it's a cool little platform if you like dinking around with a little bit of hardware. So why use a Raspberry Pi? Well, there's several places I've used Raspberry Pis, and it's kind of nice to just put a single application on it and run it on a Raspberry Pi. And I'll talk about another application a little while later about where it makes sense to put things on Raspberry Pi. But the challenge is those things used to be like $38. Right now, the processor board right now for either a Pi 4 or the newest Pi 5 is basically about $78. So that's just for the board. By the time you get the Pi dressed out with a power supply, case, a few other ads on, you're going to be pushing 120 bucks. So you have a Raspberry Pi that's really only capable of running one application. So you have to kind of scratch your head. Well, gee whiz, what happens if I spend 200 bucks and put a real PC out there? And if I use a little mini PC, run VMs on there, I can run three, four, five VMs running a whole bunch of different applications. Plus, I got something out there that I can also just run plain Windows if I want to have a playpen to play things on. So for me, I kind of went with the mini PC, and that fit my needs pretty well. But each to his own as far as what you might like. But you can see where that price point these days, that's really changed the environment for using Raspberry Pis on some of this stuff. So let me hit things on Pi-hole. What the heck is Pi-hole? So anytime that it's basically a DNS, domain name server. Mm. So when you want to look up or connect to Google, google.com. So you have a DNS that picks up that name and then converts that to an IP address, like 1111 or something like that for Google. So this is the guy that converts those domain names into actual IP addresses that can go out on the internet and find the servers that you want to connect to. So one of the things that if you go out there and do much surfing, um, like if you go out and just hunt around for Google stuff, you end up finding that you have a whole bunch of ads that get attached to it. And those ads basically get really annoying. In fact, like on cell phones these days, if you get on a cell phone and you're doing on some web surfing, the ads can actually get to the point where you can't do any of the surfing. It just covers up the application that you're trying to use to take and do your work or trying to do your research for. So a lot of people put on like an ad blocker. You can do that on a cell phone. You can do it on your PC. Well, the kicker is that web developers are smart enough to be able to see, oh, this guy on his web uh, system is running an ad blocker. So it says, yeah, we're not going to let you look at anything. So it blocks it basically when the application sees that it's that a web blocker is serving, it won't let you into the page that you're trying to take and load up. So one of the cute things about this is that this is kind of an in-between guy. It's not attached to your web browser. What it does is that you can load this guy up, and there's some really neat pages out there that you can load up into this guy. And if it sees a domain that is that ad, because all these little ads, they're really from another domain. They're from a different place in the application that's not part of the main web page, typically, not always. But when you try and say, oh, okay, I want to go off to this um, thing for selling socks to post an ad on there, this guy here will end up seeing that, oh, that's a domain out there that's an advertisement. It'll block it. Won't let that page load. Won't let that mini page load for you. So this guy ends up really seriously cleaning up um, advertisement. On an average, if you go out there and do a bit of web surfing, you'll find anywhere from 10 to 30% of the data that gets loaded onto your web page is nothing more than advertisement. Stuff you don't want, and you don't want to have to use your bandwidth that you're paying for to end up loading those things. So you can see here on the top part there, kind of the second square over, third square over, where this guy is sitting at about 13% of the stuff loading gets blocked. My wife gets on there and she can crank that number up to 25 to 30% pretty quickly when she's doing some serious web surfing for stuff. So this is a really cool application. It's Linux based. It very uses a very modest amount of resources for how it runs, and you have control over what things you want to block and take out of. And you can read through the documentation with this. Now, the page that I have up here is only about half the page. Below that, it gives you a whole bunch more statistics, but it's very rich in statistics, easy to turn off, easy to configure. I really love this little application. So this will save you a bit of time. Next one, ham clock. So this is one that's been around for a while, and I really like it. Now there's a new one that whole new system that you'll see advertised at the ham shows, but it'll cost you probably $300 to $500 to get into that club there. It does a whole lot more, but you end up having to pay for it. So this is free, absolutely no cost to it. And you all these windows all around you, you can configure for what you want displayed. And you can have multiple split displays, so it will kind of rotate through things. One of the things I really like and I use a whole lot is that window over on the right called VoiCap. VoiCap is a statistical method of predicting where you're going to get propagation. For example, let's look at the big window of the world here. See the big orange dot right in the middle? That's me. So I had selected 12 meters. I want to know where statistically I should be able to take and get to. So we know that 12 meters, if I wanted to talk to someone across the U.S., 12 meters, you can see mid part of Midwest where you don't see the green, all you see is black. I'm going to skip over that area. So that will show me visually what my skip zone, what my dead area, where I'm not going to be able to reach anybody if I'm looking on trying to get WAS or grids or whatever I'm looking for. So this is a very, very cool a thing to end up having here to be able to see that you're not going to be able to get into that mid part of the states. And then obviously as you go out further and further, that skip zone becomes bigger and bigger and bigger. So that's one of the great cute things. It also gives me on the farthest window on the right side, it gives me all the current solar statistics, sunspot numbers, solar flux intensity, K index, what the solar winds are doing. This is not updated for right now because the solar winds are off the charts. It also gives me in the second window in, gives me information on the expeditions out there, so I know what call signs to look for to try and track down. Great piece of software, easy to install, and insanely flexible. Really cool. Okay, I'm going to change a little bit here and move a little bit to a little slightly different part of the subject, but you'll see how it kind of ties in. So I keep running into a lot of guys that want to end up putting their ham station strictly on solar power, just run it off of battery and solar panels out there. So whenever you're designing this kind of a system, uh, it's all about the battery, how much energy you can keep in that battery when you don't have the mains, when you don't have AC around there to run things. So as you design it and as you look at how things work, you have to always think about what's going in, how much energy is going into the battery, how much energy are you pulling it out, how much do you have to replace. So during the winter, and this is something that a lot of people just don't think about, but in the Pacific Northwest, we are way up north. The angle of the sun is right down on the horizon out there, really, really low. The shortest day of the year is December 21st. It's And so that angle, any kind of filtering, any kind of clouds, rain, anything that comes, smoke, stuff like that, kind of filters the sun, and it will very drastically uh, reduce the amount of energy, electrical energy that is produced for your battery. So it's easy sometimes where we can go a whole week or more without any solar production because you got so darn many clouds up there, and it's just you just don't get anything out of it. So I started off a project with a repeater here, and that repeater only needs 12 watts just to maintain the receiver in the repeater and keep the thing alive. So I started it off with two 100-watt panels for 200 total, and tried running that for a while. And next thing I knew is that my battery was flat. I just couldn't find enough solar power out there to end up recharging it at 200 watts. And that's typical for this time of the year. See, so it was obvious that I needed more silicon out there. So what I did was I knew that there were used solar panels available, big ones, commercial ones that get pulled out of service every once in a while. And so I started calling my friends, doing my networking, and talked to this guy, talked to that guy, talked to another guy, and this guy got past me and another guy. And so about three or four levels of permutations, I finally found got a source. So I found a source that rather than on the left side, those are my 100-watt panels. On the right side are ones that I replaced it. Sorry, I didn't scale this correctly so you can see the size and difference. Ones over on the left side there were basically about 18 inches by about 30 inches tall. The ones over on the right, each one of those panels there are 300 watts. So that gives me 600 watts total. That panel is equivalent to picking up a 4 by 8 piece of plywood. It's not quite as tall, but as far as, and probably 5/8 of an inch thick. Those are really heavy, really big, really awkward to work with. And so I had to take that stand that I had on the left, modify it, rework it, and to be able to handle the bigger, heavier, and larger solar panels to get that thing up, connected on. But when I did connect it on and connected up my system, it's like, whoa, even in bad days, I can get enough solar energy off of those two big panels up there in order to maintain the system. I don't have enough to, if I'm at 50% and all I get is filtered sunlight, I'm going to be able to maintain it at 50 cents, 50%. I'm not going to lose any power. I'm not going to gain it. But as soon as the sunlight comes out, this past week, every day we pretty much got a little bit of sunlight that creeps through it. That dude will end up recharging that battery. It's a lithium battery, about an hour and a half, and that thing is completely topped off and equalized. It's really impressive to see how much power those things put out and how much better they are on the smaller ones. So if you're thinking about doing something in solar, think about doing what's going to happen during the winter. If you're going to do emergency type of things, you can't do it with a small set of solar panels during the winter. It just doesn't hack it. So this is what the inside of the cabinet looks like. We'll go ahead and start on the left side there. So on that very top shelf, there's some fans, fan controller. This is if you get extra heat in there, and this is all in Celsius here. It'll end up bumping up it'll turn on the fans and move all the heat out of this container. The guys at the very bottom, that contains the big black blob there on the bottom, that's the battery. It has a heat wrap around it. Lithium batteries will not charge when it's below 32 degrees. So this has a heat wrap around it that I can turn on programmatically to take and warm up the battery so it can accept the charge. The next black box above that, that's actually a 20 amp lithium battery charger that I can turn on if I need to. Of course, then I'm also drink the Kool-Aid for Victron. I really like Victron devices, and that's a Victron charge controller. And there, buried down in the back side of this guy in the deep end of it is a shunt. So that shunt is very, very important because as you work with a solar system, you always want to know what the state of charge, what the battery is, how much energy, how long can you run at that level if something happens. So that shunt basically shows me everything that goes into the battery, everything that comes out of it. Really important. So let's go hit the middle part there. So that middle part, there's actually a true sine wave inverter setting there. So this is thinking out of the box a little bit, but that repeater, the actual repeater controller, it doesn't set down here on the ground. That thing sets up about 3 feet below the antenna in a waterproof box up there. It is ventilated. But it's ventilated in a way that water doesn't can't get in there. So I run, and this is a 100-foot cord here. So basically, it runs up 50 foot up top of the tower, and runs the repeater up there. So rather than running 12 volts all the way up there, dealing with all the voltage IR drops and losses there, I decided just to run AC up there, and it's been working just fine. Haven't had any noise. I still need to get some ferrites on that to mitigate stuff. So two things that I talked about, the heater for the battery and the lithium battery charge controller. So up on the very top shelf, actually here we'll hit it on the right. Up on the very top right of the display here is a good old Raspberry Pi. This Raspberry Pi has a relay hat put on top of it. So that's a little board that fits on top of the processor. There are 3 relays in there that will handle 10 amps AC on that. So one of these guys, this guy handles the charge controller, the lithium charge controller. The second one in here, that handles the lithium or the heating blanket for it. And the third one I haven't used. So in this, you have the ability to write scripts. You can put scripts in here. Oh, this guy here is running an operating system called Venus. It's a Linux-based system that was designed and built by Victron for doing power monitoring. The purpose of this thing is that it actually has cables and you can't see all the cables, but each one of these units there, the MPP power supply and the shunt back there, all of those things connect back into this guy here through USB cables on the front of that. So it can see everything that's going in and out of the solar panels, all the power that's being generated, all the energy going in and out of the battery. So I get a complete picture of all of that stuff. This information also has the ability I can get it on my cell phone. Also connects to, I have Ethernet down at the barn there, so it can connect into my LAN, and then it also could go on to the internet there for it to the Victron site so I can visualize everything. So that little guy there, that is an amazing device as far as monitoring and changing parameters that I can do everything remotely. I can do it remotely. Good thing to think about. So that's kind of the basics of what's in that box there. So I'm just showing you another thing for doing automation if you're thinking about doing something with solar where you can remotely control and visualize what's going on in your system using a little tiny box like this, and also tapping into the Victron ecosystem. The reason I like Victron, they don't make noise. They're really, they are insanely reliable. They all integrate together and work it really well. And ham after ham after ham that I know have all eventually gone back to using or gone to using Victron systems. Really cool. So next page here, this is off the Victron website. So this is showing me all kinds of graphs and statistics on what's going on my solar system and how it's charging, what the voltages are in the panels, how much current's coming off the panels, how much is being converted to 12 volts, and blah, blah, stuff like that. It's incredible amount of information. So here's another display. The bottom part basically is one of those little windows there or panels. So you can run a cursor across that and you can see the exact time that you're looking at, the date time. You can move backwards, you can't move forward, but you can move backwards in time. All of this gets pushed into a database so you can see tons and tons of detail on that. So here we're looking at battery voltage and current. It tells you that, where those cursors are setting, battery voltage is 13.95. The current going into that battery is 18.7 amps. So obviously the sun is up. Another cute thing off of that, most people that use these things in campers, they buy a little 7 by 4 LCD display, uh, touch panel, and they'll mount it in their RV. And then this is a display of exactly what you would see if you had that panel in the RV. Although I can get that same information directly from that monitoring Pi that I was running, get the same stuff. And then this guy here, you can poke it on the menu and you can drill down into all kinds of insane information. Really, really cool. So I mentioned that another thing that both the ham radio, excuse me, both the home automation and also the Venus system has the ability to write scripts. You can write scripts in whatever they had there, but another cute way of doing it, if you're a non-programmer, you have the ability to use what's called Node-RED. And Node-RED gets used for all kinds of stuff. You even find it in ham radio. If you look, there's a whole set of Node-RED stuff if you want to design and build and create a software-defined radio, an SDR type of radio. You can use Node-RED to do it. So this is a simple graphical way where down the left side you have these common modules. You grab one of those things, drag it over. You can click on the thing, open it up. There's some parameters that you set up, like what relay or what, if you want to look at the temperature, you can grab all of that. But everything is all completely programmed. And then you just draw lines between it, hook it all together. You say deploy it, it'll check it for any syntax errors, and then it gets deployed. So it's this one here is for turning the battery charger on and off. So for me, I probably overcomplicated things, but it's a real nice, simple little flow for, I have a manual way of doing it. I have a programmatic way of doing it. I don't have to be the one managing it. That little Raspberry Pi that's down at my barn, it manages all of that for me. So I also did another automation for sprinkler system. I got tired of the stupid sprinkler system where I couldn't set individual times for each zone, for each sprinkler, for each valve out there. So this is a little, you can also build dashboards out of Node-RED. This was all built out of Node-RED. And so here's a simple dashboard for doing all of that kind of control. Pretty neat stuff. But that comes both on the home automation and also is available for specifically designed or tailored for that uh, for that power monitor. So let's wrap it up here. So out of all this, I threw a bunch of different ideas and things that I've done around here that was important to me. I'm sure everybody else has different things that's important to them. But think about ways you can automate your system, make it simpler, make it do things that you want done automatically and not have to think about it, not have to do all this stuff manually. Where I really like it in the morning, I wake up, poke a couple buttons. By the time my coffee's made, get up to the shack, everything's up and running, and I'm not wasting my time waiting for things to boot up, waiting for programs to load. It's all there for me. So, and also don't let, when you heard Linux, don't let that stop you. Things out there these days, it's all cookbook type of text. You just do a cut and paste on all the information, and you have the stuff up and going. If you get stuck on something or it doesn't work quite right, there's tons of Google information that can help you take and solve problems. But remember, there's lots of options out there to run Linux on Windows. You don't need a separate PC just to run Linux. In fact, I've loaded Linux up and run Debian, or no, Ubuntu, and loaded in all their suite for doing, email and for doing all the other kinds of things you would normally do on a PC, like Office and stuff. And it just works. It just plain works. And that's running it on a system that's the base is Windows, but running Windows as a or Linux as a VM. So anyway, that's all I had, folks. There. I was wondering if anybody had any thoughts or comments about stuff that I had kind of talked about there. And really sorry about the coughing up there, but couldn't help it.
Very impressive, Mike. I was also going to say Linux is a great alternative operating system if for old, laptops and stuff like that that you can't run Windows. Like if you got,
Yeah, you
Windows.
have right now. There's abundance of stuff that can't run Windows 11. So there's an abundance of workstations, laptops out there you can get for nothing if you want to run a pure Linux system on it. Yeah, I had to give up a very, very nice processor, good horsepower, tons of memory, great workhorse workstation. Had to gut it out and replace it with all new stuff so I could move on to Windows 11. So I have a free motherboard and processor if anybody wants it, memory. Any other comments or thoughts out there? Or did I put everybody to sleep or
Well, I've been using Home Assistant for years now, both at home and at work, and it's a wonderful tool. And it's even the last few years, it's matured significantly from something that was very usable by with moderate tinkering to something that's pretty usable for almost general public, pretty largely.
yeah. And I have to say all the Linux stuff that I played with has been insanely reliable. It just works. Home Assistant being this open source, they do a pretty good job of monitoring it, but occasionally you can get a bad update there or one that doesn't do what you want, but they are very responsive in getting things fixed and turned around, unlike Windows where you can have to wait months or years to get something basically fixed. So, and that's one of the things I have no tolerance anymore for things that are dodgy. I really, whatever I put on my system here, it's got to be bulletproof. It's got to work flawlessly, or otherwise I consider it junk and it gets thrown to the side. So all of those tools and all those things just work. Anything else? Then ready to kind of close up shop and head off. I don't know if the football game is still going on, but I got robbed of watching the championship football game for college. Bummer. I'm just whining. I keep hearing my wife downstairs yelling and screaming and stuff about stuff going on, so I know it's got to be good.
Well, it looks like Paul took off, so I'll wrap it up. And thanks, Mike. And we'll catch everybody here in about a month. So have a good night, all, and we'll see you in February.
All right, everybody, have a good one.
We'll see you.